Hello and what's up, everyone? We're back today with another lesson, and we're starting a whole new unit. This unit, we're going to be talking about circles, and we're going to get into shapes, same thing that we've been doing, shapes on the two-dimensional level, shapes on the three-dimensional level. And this first lesson is going to start off by kind of using both those ideas, the 3D shapes and the 2D shapes, because we're going to be talking about cross sections. So basically, what does that mean? It means if we cut a shape, the surface that we cut it at, what shape does that make? So for instance, if we cut this cube that we see, if we slice it like a piece of bread, what two-dimensional shape would be the surface that we cut at, which would be like a rectangle or a square, right? And those are the types of ideas that we're going to get at. Let's start with our warm-up questions, though. And what I want you guys to try to do is pause the video, look at these warm-up questions, think about them for yourself, and then click play on the video and see what my answers are. So for the first one, we have a cube. And this is how many faces does this cube have? So we have to think in three-dimensional shape, right? Because not just the faces that we could see. If it was only the faces we could see, it would be 3. But then that means we're missing a whole chunk of this cube. We have to think about what this cube is. We have our front here, which is 1. We have our back, which we can't see, which will be 2. We have our top, which is 3. We have the bottom, what we can't see, which is 4. And then we have our right, which is 5. And then we have the left side that we cannot see, which would be the 6 sides. So we have 6 faces here. Next up, edges, which means these lines that we have here. So now we need to think about that. And once again, we have to picture the ones we cannot see. So up top here, we have 1, 2, 3, 4. We could assume that the bottom is going to look the same. So that would be 5, 6, 7, 8. And then we have all the supports that connect the top and the bottom. So 9, 10, 11, and 12. We'll have 12 edges. And last but not least, we want the vertices, which are these pointy parts. So we have 1, 2, 3, 4, 5, 6, 7, and then one more back here, 8, that we cannot see. And there we go. We have all our answers for our first one. Now, if you didn't try these yourself yet, like I asked you before, make sure you click pause now that you have an idea, and let's try the next one ourselves. All right, so let's go over the answers. How many faces do we have? This one's a little easier because they show us through the shape. So we could see the back of this shape, which is over here, right? So we have a pyramid here. We have a square-based pyramid. So the base is 1. Our front side here is 2. The right side, 3. The back, 4. And our left side will be 5. This pyramid has 5 faces. Next up, edges. We have our base, 1, 2, 3, 4. And then we have our lines that come up to a point here. So 5, 6, 7, and last one back here is 8. Awesome. Next up, vertices. Well, how many points do we got? We got 1, 2, 3, 4 at the bases, and then 1 up top, which will give me 5. Awesome. Now let's go over our last one. We have a prism. What type of prism? This will be a pentagonal prism. Why is it a pentagonal prism? Because our bases here, the front and the back, are pentagons, 5-sided figures, right? So it's a pentagonal prism. I like that alliteration. Pentagonal prism. Right? So how many faces do we have? We have our front, we have our back. So that's 2. We have the bottom, we got the right side, we got the top right, the top left, and the left side. So let's count them. 1, 2, 3, 4, 5, 6, and 7. This will have 7 faces, which makes sense because we have our 5 sides around the outside, then the front and the back. So 5 plus 2, 7. How many edges do we have now? So now we have to get careful because we have to count the 5 here on our pentagon, the 5 for the back pentagon, which will give me 10, and then each line that connects them. So 1, 2, 3, 4, 5. So we have total 15 edges. And last but not least, vertices, aka these points. Where can I poke myself with? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And there we go. We identify parts to all of these figures, and we got our brain going a little bit, did a little bit of a warm up. Now let's jump into our lesson. So our lesson's called Any Way You Slice It, and we are talking about cross sections. So our learning goals for today is to determine the shapes of cross sections and determine the shapes of intersections of solids and planes. So let's start. It says, consider the three-dimensional solids shown. How can you intersect these to form a point, a line, and a plane? So for each of these, we want to create an intersection that will do each of those things. Give us a point, give us a line, and give us a plane. So we're going to do our points, intersections in red. We'll do our line intersections in, let's say, green. And then we'll do our plane intersections in purple. So for our point, let's do all the points on the first one. In order to do a point, it has to just touch our shape at one spot, right? Because a point is one solid location. So for this cylinder, if we had a line that was going, it would have to just touch that tip right there, right? This line could go on forever, but would just touch that tip. Same thing for the cone, right? The easiest would be the point right up here. We would want to intersect that. Boom. Just touch at one point. The cube would be the same thing, and you could do this at like multiple different spots on this cube, but the ideal would be just touching that point right there. And then once again, our pyramid, just touch at one point. Boom, boom. Now, we could all have different answers here. There's a lot of other possibilities where we could do this, but for right now, it's just these points, right? So next up, we want to do lines. How can we create a line? Well, create a line. Let me see, green. What we could do is follow along the edge, right? So if we have a line that came straight down my cylinder here, boom, boom. Right? There we go. We got a line. Even if we intersect it with a plane, right? If this green line was a full plane, it would still only give us a line if we just skimmed along the edge of the cylinder. The same with any of these, right? If I had a plane that just came along the edge, let's say this is my plane, something like this, but it would be touching right here at this line along the edge of that cone. The same with a cube. If we could just follow one of these lines. Let's have a line go like this. Right along the edge. Boom. There you go. And pyramid, we could choose any edge here. So for instance, one like this. And it would give us an intersection of a line. And the last one is a plane. And the plane is kind of what we're actually talking about today, right? Because of these cross sections. So if I have a plane and I was to slice this cylinder almost like a cake right down the middle, something like this, right? Oh, let me make it dotted, right? So we got to go. Their plane looks like, hard to draw in 3D, right? Let's say we sliced it like this. Something like that. Not a good drawing, but all in here, right? All in here. We have the solid plane that we cut this cylinder with, right? All in there. Let's say we slice that cylinder. It's going to create a shape that kind of looks like this. Boom. 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 Something like this right here, right? They had this cylinder that looked like this. And this would be the surface that we're looking at up there. That would be our plane. The same with this cone. And we might not even want to slice it, right? If we just ran a plane down at the bottom of this cone here, right? Actually, I need to make that dotted because we're behind it, right? So let's say we have this cone, right? And this would be our plane right here where it intersects. The circle that is the base of this cone. If we just ran a plane along the bottom, this is another way we could get a plane out of this for an intersection point. But all of these are about the same. We could just slice it. If you slice it like a cake, it would give you a plane as an intersection point, right? Something like this, our intersection would be all in here, right? It would be all of our intersection point. And same with the last one. And we could do this in any direction we want. Let's say this one, want to slice it going across the top like this. Something like that, right? We'd get an intersection in here that would kind of look, let's say like this. This is harder for me to draw. It would look something like, oh, didn't mean to do that. Actually, I can't even draw this, to be honest. Basically, it would give us a triangle as our intersection point right there as a surface. Surface that one would be a triangle when we slice this edge of this. Just think about slicing anything like a cake. Awesome. So, two-dimensional cross sections. A section of a tree trunk is roughly the shape of a cylinder, as shown. So we'll have a tree trunk here, and the tree trunk is basically a cylinder. When the tree trunk is cut, in order to see the tree rings, a cross section of the tree trunk may be studied. So our cross section of the tree trunk here would be all this, the top, right? Top of this tree trunk that we have here, which is what shape? A circle. So when we cut a cylinder like that along the line, it's going to give us a circle as our cross section, right? So determine the shape of each cross section and then sketch an example of the cross section, right? So this one says, suppose a plane intersects the cylinder parallel to its bases, which means that our plane is going to cut it something like this, right? So when it's cutting it, it's going to look kind of like this right there, right? And this is going to be our intersection point. Now, it looks weird because we're looking at it from an angle, so it almost looks like an oval. But if we were to look straight down on this, it's like that tree trunk that we saw before, where it's just going to give us a circle, where whatever the radius is here, r, is going to be the same radius on this circle here, r, right? So it's going to give us a circle that is the same as the bases of this cylinder. It's going to look exactly the same because the cylinders don't change as we run along them. They stay the same shape and size. Next up, suppose a plane intersects a cylinder perpendicular to its bases so that the plane passes through the centers of the bases. So let's say our plane is going this way now, right? Something like that, right? Plane looks like this. So it's really just kind of cutting along in here like so, right? Like something like that. Now, what shape is that going to be? So it's kind of hard for some of us to picture. But what it's going to give us is a rectangle, right? Where the rest of this rectangle would kind of look something like this, right? That would be the back of it, which is the top or half of the top of this cylinder. Right? You'd have like lines coming down here, look something like that, right? But we'd have a rectangle where this is our height and this is the diameter, right? Up top here would be the diameter of our circle, or the base, and the going up and down here would be the height of the cylinder. All right, for our next one, it says determine the shape of each cross section, right? Same thing that we've been doing. But this one says suppose a plane intersects a cylinder so that it is not parallel to the bases and does not intersect its bases, right? Now this one's a little harder to visualize because we need a diagonal plane here. So I got a little tool that I found, which I'm going to be pulling up on the screen. So as you could see, this tool right here shows us this exact situation. The plane is cut in through this cylinder, and here we go. We got the cross section. Now, what do we notice about this cross section? The cross section is still just a circle, right? It's going to be a differently shaped circle, but it's still going to give us that circle. So the same thing would apply here, right? We had this, and if I tried to draw it, let me try to draw it here. So it looks something like Oh, that's not a line. There you go. Something like that, right? Our cross section will look something like this here, right? Let's pretend like that's the cross section, which is just a weird looking circle. Once again, I'm not good at drawing these circles. There we go. Something like that, but it's on the diagonal cutting through. Oops. So here we could see a lot of these ideas put in use, but now with the sphere. It says, consider the different cross sections of a sphere shown. Identify the two-dimensional cross sections of a sphere. Well, no matter where we cut a sphere, what's going to happen here? Bars. All of them are going to give us circles, but they will be circles of different sizes, right? So the biggest circle being if we cut it perfectly down the middle of the sphere at the diameter, where cut through the center of the sphere. And then we can make it smaller by going up or down on the sphere somewhere. That's how you could change the size of the circle. Next up, consider a cube. Sketch and describe 5 different two-dimensional cross sections formed when a plane intersects a cube. This one, we really need to think about it, right? We want to cut it in 5 different ways. So first one, boom, boom, we'll go down the traditional route. Right down the middle. Actually, let me try to do this so it looks a little more three-dimensional. We're cutting it in front and back. Just like that, right? There it is. We cut it right down the middle. It's going to give us a square right in the center of this cube. Next one, what can we do? If we cut it going up and down, it's still going to give us that square, right? Because we're dealing with a cube here. But it's going to cut up and down. We could do a diagonal where we have our plane that cuts through kind of like this, right? It's still going to give us a square or a rectangle, right? But then we could get fancy with it, right? And we could cut it so just maybe slicing off the tip of this sphere like so, right? So then it only intersects it right somewhere like that, right? Slicing off that middle part. And then we could do that in different ways and different shapes and sizes. So what else can we do here? But once again, look what it gives us here. It's still giving us that square, the rectangle shape, right? There's really not many options to try to get a different shape out of this than doing that. So what's our last one? Let me think about it. What can we do here? If we cut something like this, boom, 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 so that we're cutting across with a big rectangle in here, kind of looks like this, right? It would be intersecting right there, right? Slicing off this whole edge up top. There we go. We got 5 different slices, 5 different cuts on our cube. The next one is thinking about a square pyramid, right? And it says sketch and describe 4 different two-dimensional cross sections formed when a plane intersects a square with a pyramid. So if we intersect at the base, we could get a nice square, right? But you could change the size of that square depending on where you intersect it. So if we intersect up here, it's going to look different. But if we intersect going up and down, right? If the plane intersects it like this, right? We're going to get a triangle. Cool. Now we got a triangle. But we could have other options, kind of like what we did with the last one, where if we intersect it here, boom, 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 we have a smaller triangle where we're slicing off the edge of, or the tip of one of these points at the bottom. We'll have a smaller triangle within this cross section. So we have a bunch of different cross sections we could do here. We could do the biggest square at the base. Anytime you move up along it, it's going to make that square smaller and smaller. You could cut it up and down the middle. You could cut it at a diagonal to create different shapes of triangles. And that's all we have. So this was all just kind of an idea and once again, getting us to picture these shapes in our mind, right? So it's all about building that part of our brain, kind of like an imagination. So think of SpongeBob, if you guys remember that, where he goes, imagination. So that's what we're trying to do here. We're trying to get that ability to come out by picturing these shapes and thinking about slicing them, and seeing what we get from that. So I hope you guys learned a little bit of something today. As always, if you have any questions, comments, or concerns, feel free to reach out to me. Drop a comment down below. Talk to your teacher about this too. We're here to help. So I hope you guys have a great rest of your day. Enjoy and peace out, everybody.